You know that feeling? Just scrolling through your phone, thumb flicking past an endless stream of updates? It seems so simple, so effortless, right? But what's really happening behind that smooth scrolling screen? Well, it's a wild feat of engineering. So today, we're going to pull back the curtain and see exactly how it's all put together.
All right, so let's put you in the driver's seat. Imagine this. You've got to build a newsfeed app, not for a few hundred people, but for 500 million users. Yeah, 500 million. Where do you even start? That's the massive puzzle we're going to solve right here, together.
So here's the game plan. We're going to tackle this in 4 parts. First up, we'll figure out what exactly we're building. Then we'll look at how the app actually talks to the servers. After that, we get to peek under the hood at the app's internal design. And finally, we'll get our hands dirty with the really tricky real-world problems that pop up when you're building for a user base that massive.
Okay, first things first. Rule number 1 of any huge project like this, you have to know what you're building. I mean, before you even think about writing a single line of code, you've got to get super clear on the scope. What are the must-have features? And just as important, what are we leaving out for now? So, let's lay out the essentials. For our app, the absolute must-haves are an infinite scrolling feed, obviously, the ability to create posts with all the good stuff, text, pictures, videos. You've got to be able to like and share things, of course. Tapping a post needs to open up more details. And here's the big one. It has to work offline. You're in a subway, you lose signal. The app can't just die. That's a deal breaker.
And now, for the number that changes the entire game, 500 million monthly active users. Seriously, let that sink in. This isn't just some vanity metric. It's the single biggest constraint that's going to shape every single technical choice we make from here on out. Because what works for 1,000 people, well, it's going to explode into a million tiny pieces at this kind of scale.
All right, we know what we're building. Now let's talk about how. Let's get into the technical backbone. How does your phone get all that content from some giant server farm miles away? It all boils down to the API. Think of the API as the secret language, the set of rules that lets the app and the server have a conversation. For this conversation, we're going to go with a classic, HTTP with REST APIs. Why? Simple. It's the industry standard. Everybody knows it. And the best part is that it's stateless. That's a fancy way of saying each request is a fresh start, which makes scaling up our servers way, way easier. Sure, it's not perfect. Sometimes you get a little more data than you need. But when you're building something this huge, you start with what's battle-tested and reliable. It's the smart play. Okay, so the data's coming over REST, but what does it look like? We're going with JSON. It's just a perfect middle ground. It's easy enough for a human developer to read, which is a lifesaver for debugging, but it's also compact, so the file sizes are small. And that is absolutely critical when you think about someone scrolling on a shaky 3G connection or a limited data plan. JSON just nails that balance.
Now here's a super important detail for that infinite scroll. How do you actually get the next chunk of posts? You can't just ask for page 2, right? Because in the seconds it takes you to scroll down, 100 new posts might have been added, and now page 2 is totally different. The whole thing would be a mess. So instead, we use something called a cursor. It's like putting a bookmark in the feed. The app tells the server, hey, see this post right here? Give me the next 20 after this one. It's a really clever way to keep the feed perfectly stable and consistent, no matter how fast new stuff is coming in.
Okay, so we've sorted out the communication between the app and the big servers in the cloud. Now let's zoom in. Let's look at what's happening inside your phone. What's the architectural blueprint that lets the app juggle all this data without crashing and burning?
The model we're going to use is called Unidirectional Data Flow, and it's exactly what it sounds like, a one-way street for all our data. It's super predictable. Data comes in from the network or from local storage. It goes through this central hub called a repository that handles all the logic. And then, and only then, does it get shown on the screen, the UI. This one-way system makes everything so much easier to track down and fix when things inevitably break.
And this right here, this is the secret sauce. This is what makes our awesome offline mode work. It's a principle called the single source of truth. And the rule is simple but powerful. The screen, the user interface, is never, ever allowed to talk directly to the network. Instead, the network's job is to update a little database that lives right on your phone. The screen only reads from that local database. So think about it. Whether you have internet or not, the screen doesn't care. It just shows what's in the database. It's the key to making an app feel rock solid.
So we have the big picture, the high-level blueprint. But you know what they say, the devil is in the details. Now we get to the really fun part, The nitty-gritty, tough-as-nails problems that separate a good app from a great one, especially when you're dealing with a global audience. So, for that little database on the phone, what kind are we going to use? We're going with a relational database. You might think that sounds a little old school, but it's perfect for this. A social media post is very structured, right? It has an author, a timestamp, likes, comments. All these things are related. A relational database is a champ at handling that kind of structured data, letting us do really powerful searches and keeping everything consistent, which is exactly what we need for that slick offline mode.
Okay, let's talk about a classic scenario. We've all been there. You're on a subway, the signal is terrible, and you hit the like button on a post. What happens? Does the app just freeze? Does it pop up with an annoying no connection error? Or is there a more elegant solution?
There absolutely is, and it's a beautiful trick called optimistic writes. Here's how it works. The second you tap that like button, the screen instantly updates. The little heart icon turns red. It looks like it worked immediately. It's optimistic because the app is just assuming the server will eventually say yes. Meanwhile, in the background, it puts that like action into a little queue, and as soon as your phone gets a signal again, it sends it off to the server. The user gets that instant, satisfying feedback, and the app feels lightning fast.
And that's the whole point, right? Perception is reality. What optimistic writes do is create the perfect illusion that the app is flawlessly responsive. To the user, there's no lag, no waiting, it just works. That feeling, that sense of speed and reliability is what makes an app feel magical.
Speaking of that feeling of speed, nothing kills it faster than a laggy, stuttering scroll. And a huge part of that comes down to how we display the posts themselves. With bold text, links, all that stuff. Now, the easy way out is to just embed a little web browser view for each post. But that's a performance nightmare. It's slow, it eats up memory. The right way, the harder way, is to build it all using the phone's native UI components. It's a lot more work for the developers for sure, but the result is that buttery smooth scroll that users expect. For our 500 million users, there's no other choice.
You know that horrible feeling, right? You're trying to scroll and the screen just hitches. It stutters and jumps. In the developer world, we call that jank, and it is the absolute enemy of a good mobile experience. So what's actually causing that? And more importantly, how do we architect our app to make sure it never happens?
Basically, jank happens when you're asking the phone to do too much, too fast on what's called the main thread. That's the part of the app's brain that's in charge of drawing everything you see on screen. Things that clog it up are classic offenders, loading massive images without shrinking them first, creating super complicated layouts, or just being sloppy about how you reuse the little building blocks of the list as you scroll. A truly great app is obsessed, absolutely obsessed, with keeping that main thread as lean and free as possible.
All right, let's wrap this up. What's the master blueprint here? 4 key takeaways. 1. Scope first. Know exactly what you're building before you do anything else. 2. Scale changes everything. Designing for 500 million people forces you to make different choices. 3. Offline is not an afterthought. Build for the real world from day one with a single source of truth. And finally, number 4, perception is reality. Use tricks like optimistic writes to make your app feel instantaneous, because that feeling is what matters most.
So there you have it. We've just designed a rock-solid, scalable newsfeed. But let's be honest, the feed is just where the story starts. The real action, the engagement, happens in the comments. So that leaves us with a final, massive question. How would you design a real-time comment system for this thing? A system that can handle millions of people replying and reacting all at once in real time? Now that's a whole other can of worms, isn't it?